Hello students, it's really happy to meet you again in this class. Today we see 11th chemistry unit 6 gaseous state and our today topic is Challis Law. This is Gopal from Department of Chemistry, Bharathidhasanar Matric High Secondary School, Arakkonam. Let's see students, we already know that the gas laws are Boyle's law, Challis Law and Avogadros Law. In the previous class we already discussed about the Boyle's law. Now we see the Challis Law. So Challis Law is nothing but it describes the two terms volume and temperature. We already seen the relationship between pressure and volume in Boyle's law. So today we see the relationship between temperature and volume, and one more Avogadros law, consider the volume and number of moles. We will see it in later. Let us go to the Challis Law now. Let us see students, in Challis Law we describe about the volume and temperature. Let us see, if we put a graph in between the volume and temperature, how the curves are obtained by this variation. Let us see, in a reaction chamber the gas molecules are present here. The temperature of molecules is represented by the thermometer and the pressure is represented by the pressure monitor. Let us see in which the constant pressure is taken, because when we see the variation between two terms, the another terms, the third term should be in constant. We see the variations in volume and temperature only, so the pressure should be constant. So pressure is kept as 1.5 atmosphere as a constant atmosphere for these molecules. So pressure constantly maintained means the volume should be differ, because if the temperature is increased, the molecule can absorb the heat energy. So due to increasing heat energy, the molecules can get converted into its kinetic energy. So due to the kinetic energy, the molecule can move from one position to another position. So due to the vibration of molecules, it needs more amount of volume space. So when we require the volume, we need to give a flexible volume to the molecules, because then only the pressure should be maintained in the same. So volume is changes as per the temperature changes. How it changes? If we increasing the temperature, look at here, the volume also increases. So as per the temperature increases, the volume also increases to maintain the constant pressure. So by these values, we record the temperature value and volume value, means take a temperature in x-axis in degree Celsius or Kelvin. Now I take the temperature in Kelvin unit and volume in ml unit, means I will put a mark for a particular temperature, how much volume for the gas is obtained, I put it as a mark. So as per I note the marks for volume and temperature in different conditions, in different periods I take different volume and I get different temperature, means after I put in the points in the graph, when I connect the graphical points, I get a straight line curves. So these curves denotes that increasing in the volume as in the height and increasing in the temperature as in the left to right the curves grows up. So we can see volume always directly proportional to temperature. So this is the mathematical representation for Challis Law. Volume is directly proportional to temperature. So if we put equal to volume and temperature, means V is equal to K into T. So this is a mathematical representation for Challis Law. So for the Challis Law, we can write the equation V is equal to KT, but this condition is at a constant pressure. So constant pressure, the volume should be directly proportional to temperature. So this is Challis Law. After knowing this, we can know about the Avogadros Law. So this is the third law in gas law. Avogadros Law describes about the volume and number of molecules. So N here represents the number of moles of the gas molecules. Let us take two containers, in which the first container the number of moles is differ from the second container. So the first container's number of moles is represented as N1, and for second container the mole number is N2. So, number of moles differs. You can see the second container only contains large number of moles than the first container. So, first container contains less number of moles, so the volume also decreased. Why the volume decreased? Because they are maintained the constant pressure and constant temperature. To maintain the constant pressure, the volume get decreased. So, same constant pressure is maintained in the second container, but the number of moles increased in these gas molecules, so the volume also increased. As per the number of moles increases, the volume also increases at constant pressure and temperature. So, this is definition for Avogadros law. So, the mathematical representation for Avogadros law can be written as V directly proportional to N. It means that volume decreases with number of moles decreases, volume increases with number of moles increases at constant pressure and temperature. So, if we put equal to for V and N, we can add a constant V is equal to N into K. So, this is the mathematical representation for Avogadros law. By knowing this law, you can know all the laws for gas laws. So, the three laws only, main laws for the gas laws: Boyle's law, Challis law and Avogadros law. In Boyle's law we discussed about the pressure and volume. In Challis law we discussed about volume and temperature, and Avogadros law give a definition in between volume and the number of moles. So, let one thing you see, you know the Boyle's law. From this law you know that P directly proportional to 1 by V, and you know the Challis law. In this law V directly proportional to T, Avogadros law. In which V directly proportional to N. Let us consider the terms with the volume. The volume is always directly proportional to temperature. So, I take this from Challis law, and volume directly proportional to number of moles. So, I take these terms into from the Avogadros law, and the pressure is inversely proportional to volume. I take this term from the Boyle's law. So, when I combined these three laws, I get V directly proportional to T N divided by P. Volume directly proportional to temperature, number of moles, and inversely proportional to pressure. If I add a constant, in which means V equal to N constant R into T divided by P. So, here the R is an universal gas constant. R is the universal or is the universal gas constant. So, this R universal gas constant is added with this. So, the equation is finalized. This final equation is the combined law for Boyle's law, Challis law and Avogadros law. You know students, this gas law is called as ideal gas equation. So, this equation is simply represented as PV equal to nRT. This equation is ideal gas equation. This equation is ideal gas equation. So, according to this, we know that if the gas obeys all the laws, Boyle's law, Challis law and Avogadros laws, means that gases are called as ideal gases. So, from the laws we can form the ideal gas equation, and the character of ideal gases also we can easily know by these formulas. These are the terms we see today. And students, in the below description you have the study material. In the study material you have your book back questions and additional questions. The answers are given in stepwise, and self assessment question paper also added. You can write the self assessment test and give us a photography for corrections. Thanks for making time to watching this video. Thank you.